Hello everyone, myself Chendu, a chemical engineering student from VNIT Nagpur. In this video, I will discuss about a analytical ultracentrifuge. Before diving into the topic, let's see some of the contents which I have included in this video. First thing is overview. In this video, we will discuss about the overview how an analytical ultracentrifuge is, and second thing is working principle. How a analytical ultracentrifuge works and on which principle it is based on. And third is the schematic diagram, how a analytical ultracentrifuge looks like in a diagramic form. And fourth is the components which are included in the analytical ultracentrifuge and the graph of which the AUC gives. And also we will also discuss something about advantages and limitations of AUC, and we will also discuss about applications of a analytical ultracentrifuge, and lastly we will discuss about summary. This image is the analytical ultracentrifuge, how it basically looks in a laboratory scale. Firstly, we will discuss about the overview. What is a centrifugation? Centrifugation is nothing but a process that involves a centrifugal force for sedimentation of heterogeneous mixtures with a centrifuge. And the second thing is, what is analytical ultracentrifuge? Analytical ultracentrifuge is a high-speed centrifugation technique for studying the molecules in a solution. Key function of the AUC is nothing but analyzing the properties of a macromolecules in a solution. Why do we use the analytical ultracentrifuge? The main reason why we use the analytical ultracentrifuge is because it is a non-destructive technique, and it also does not require any chemical modification. What is a chemical modification? Chemical modification refers to any alterations made to the molecule structure by adding or changing its functional groups. And the other reason why we use AUC is because it is highly accurate for complex sample analysis also. The applications of this AUC is determining a molecular weight, shape, interactions, and conformational changes. Now let us talk about the basic working principle how a AUC works. The basic principle AU analytical ultracentrifuge is analytical ultracentrifuge separates molecules based on the sedimentation rates under the centrifugal force. Here is a simpler way to understand how a AUC works. Now let's talk about how it works based on a five points. First thing, loading a sample. We know that loading a sample is important in any analytical process. First thing, you start by putting a small amount of your sample like protein or any molecule in solution into a tiny container into the AUC machine. In the loading a sample method mechanism, there will be two samples which we will be loading. First thing is a sample and second thing is a reference cell. We know that sample is something which have solute plus solvent, and reference cell is only having a solvent. And second thing is spinning at high speed. We know that AUC works on a centrifugation principle, so for centrifugation we require a motor which spins. The machine spins the sample very fast. The spinning creates a strong force that pushes the molecules outwards, kind of like how things fly to the edge of a spinning merry-go-round. And third thing is the separating molecules. Larger or heavier molecules move outwards faster, while smaller or lighter ones move more slowly. This causes the molecules to separate based on their size and weight. Watching the movement. The in the analytical ultracentrifuge has a special detector that watches the molecule as they move. It tracks where they go, how fast, showing how they spread out over time, how the spread of the molecules is happening over the time. Now analyzing the data. From these movements, the mission software calculates details about the molecules like how big or heavy they are, whether they stick together or interact with each other. Now let's see the schematic representation of analytical ultracentrifuge. This is the schematic representation of analytical ultracentrifuge, how the analytical ultracentrifuge works. Like basically it consists of a UV light source, a light source. It consists of a motor which is attached to this spinning rotor, which will have a two holders. One thing will be a sample holder, and here we will keeping a reference cell, or you can differential, or you can even say that counterweight balance. And this motor or rotor moves in a very high speed, like you can even say that 20,000 rpms to 1 lakh rpm, which is a very high speed. So in order to make sure there will be no resistance of airflow when it is spinning, and it can even create the heat, so we will make sure we'll use a vacuum pump to create a vacuum inside this chamber. This is a chamber whole this whole chamber is covered with a cooling uh, chamber, where the cooling will happens to decrease any heat. And this is the UV light source. The UV light source passes through the sample holder, and it will come from a exit slit to the mirror. This mirror will passes through the lens, which will collect the all the different collect the specific wavelength, and it sends it to the detector, where the detector uses its work. Okay, now let's talk some of the components which we have seen in our previous slide. The components in analytical ultracentrifuge. We have saw a light source. The light source of AUC, essential for providing optical signal, need to be track and measure the behavior of molecules. First will be a light source, and second component is rotor. This is a crucial component that performs function of spinning sample at extremely high speed. It operates at very high rotational speeds, often ranging from 20,000 to 1 lakh rpm. As I have said earlier, it uh, it is a very high speed rotational speeds. And vacuum pump. Vacuum pump AUC operates at extremely high rotational speed. Without a vacuum, air resistance would be generate heat and friction. The vacuum system removes the air around the rotor and allowing it to spin faster without any resistance. Mirror. We have saw a mirror in our schematic diagram. We generally use quartz mirror as we are using a UV light. The mirror reflects the light that passes through the sample. The reflected light is then detected by the detector. Lens. The lens helps direct and focus the light, enabling the AUC system to detect how molecules move, separate, interact, ultimately helping researchers gather the data for analyzing. Detector. Detector is also an important component in our AUC. The detector in AUC helps gathering the necessary data to understand how a molecules behave under a centrifugal force. Now let's discuss about the components briefly. First thing of the component is a light source. We know that light source in AUC is very important. Specifically, it uses a wavelength of ultra UV and visible wavelengths. So first thing we use as a UV lamp. This is a schematic of a UV lamp, how the UV lamp looks like. The range of its range of the UV lamp is 200 to 400 nanometer. It is common for detecting proteins and nucleic acids. And second light source which we will use is high intensity xenon flash lamp. This is a schematic representation, a schematic diagram of this xenon flash lamp, which enables use of wavelengths from 190 to 800 nanometers. And third light source which we use is a fluorescent lamp. You can even say that normal household lamps which uses a fluorescent thing. And the range of this lamp is 400 to 700 nanometers. Use it for a low concentration samples, offering a high sensitivity. Now, as we all know, after the light source, the most important component in any analytical instrument is its detector. How there are three types of detectors in AUC. UV visible adsorbent detector. How it works? First detector and how it works. Measures the amount of light absorbed by sample at specific wavelength, UV or it can be visible range. As the sample is centrifuged, the molecules move and their concentration at different radial position changes. The changes in the concentration affect light absorption, which detector continuously monitors. It is a continuously monitoring device. This detector provides real-time data on how absorption changes as molecules sediment. The use of the this detector is ideally for analyzing a samples that naturally absorb light, such as proteins, which absorb around 280 nanometers, nucleic acids, which absorb around 260 nanometers. This provides the information on the concentration distribution of molecules as they separate during centrifugation. Now let's talk about a second detector which are generally used in the AUC, interference detector. Before talking about the interference detector, let's see what is a interference. Interference is a nothing but a phenomena of a multiple light waves interacting with each other under certain circumstances, causing the combined amplitudes of the waves to increase or decrease. This is nothing but a multiple wavelengths interacting with one another under certain conditions. Now let's see how the interference detector works. It measures the change in light interference caused by movement of particle in the sample. As the particles move during centrifugation, they affect the phase of light passing through the solution. This change in light interference are detected. These changes are to be detected by this detector and used to interfere the concentration and position of the molecules. Use it is generally used for used for studying samples that does not absorb light strongly or not at all, such as proteins in their native state. Particles that does not rely on light absorption, making it suitable for non-absorbing or low concentration low absorbing samples. Now let's see about the third detector, which is a fluorescence detector. How it works? It measures the light emitted by molecules that are fluorescent or have been tagged with a fluorescent label. When exposed to a specific wavelength of light, these molecules emit light at longer wavelength. This detector captures the emitted light to track the movement and concentration of the molecules during the centrifugation. The major use of this detector is used when the sample is naturally fluorescent, allows the highly sensitive measurements, particularly used for detecting very low concentration of molecules. We know that graph for any analytical instrument is very important. We need to understand how a graph looks like for any analytical instrument. This is a graph which looks like this is the graph for AUC detector. The graph typically produced by an analytical ultracentrifuge experiment is known as a sedimentation profile. It plots the optical signal such as adsorbance or interference. Adsorbance, it can be adsorbance or interference versus the radius during the centrifugation. Now let's see how a graph uh, looks like. From this graph, as you can see, these each line on the graph represents a wavelength scan as the protein sediments to the bottom of the cell, the wavelength flattens. These are the wavelength scans for of the protein. The distribution movement over time is used to calculate the sedimentation coefficient, diffusion coefficient, mass, shape, molecular weight of the solute particles under the study. It does not require a sample modification. It analyzes the molecules in their native state. It is highly accurate, provides the precision data of molecular size, shape, and weight. Real-time analysis. This monitors sedimentation and movement during centrifugation. Versatile detection works with various detectors. As we have seen the three detectors, adsorbent detector, fluorescence detector, and interference detector. And it is also a non-destructive technique, does not alter or destroy the sample. We can even detect the low concentration sensitivity, detects molecules at very low concentration as well. The only limitation that AUC has is it is a high cost equipment and it requires a specialized training to operate this AUC. It is also high speed conditions may improve the sample stability sometimes. Now let's talk about applications of the AUC. The analytical ultracentrifuge is majorly used in various industries, but let's talk about the five major industries where AUC is deeply integrated. Biotechnology and pharmaceutical industries. These industries use AUC mainly for protein characterizations, monoclonal antibody stability, and protein drug interactions. Nanotechnology. AUC is used for nanoparticle size, shape, and aggregation analysis, structural biology, studying protein interactions, molecular complexes, and conformational changes. Environmental sciences, analyzing environmental particles, pollutants, and colloidal stability. Material science, polymer characterizations, particle size distributions, and material stability in solutions. In this video, we have deeply discussed about AUC, how it works, the basic principle, working principle, and a schematic diagram, how the graph works. Now let's talk about the summary and importance of the AUC. Summary. Analytical ultracentrifuge is a technique used to study the physical properties of molecules in a solution such as proteins, nucleic acids, nanoparticles. By spinning sample at high speeds, generates the centrifugal force, causes molecules to sediment at different rates, which are monitored by detectors like adsorbent interference fluorescence. AUC provides the data on molecular size, shape, interaction without modifying the sample. It can analyze the complex mixtures, low concentrations, molecules in their native states. Applications include biotechnology, nanotechnology, structural biology, environmental science. AUC is essential for studying molecular behavior, interactions, and stability. The importance of the AUC is essential for biochemical and pharmaceutical research, provides accurate real-time data on molecular properties in their natural state, critical in developing therapies and diagnostic techniques. And I would like to thank my professor, Dr. Mahesh and Verma sir, for giving this opportunity to make a video on this analytical instrument. Thank you.